In this problem, we have a composite area that is made up by several standard shapes, and we need to determine the moment of inertia of this overall shaded area about the x and y axis respectively. So let's first divide it into component standard shapes. So we can easily decide that this is, here we have a triangle, that's our area number 1. We have a rectangle right here, area number 2. We have quarter circular shape right here. That's our area number 3. And lastly, we have a negative area, which is a sphere. So what we're going to do is we're going to calculate the area moment of inertia of each of these component areas with respect to x-axis. Let's do x-axis first, and then we can just basically add them together, except that, of course, when we have a negative area, we need to do subtraction. So if we can find ix1 and then plus ix2 plus ix3, but then minus ix4, that will equal to our total ix with respect to the same x-axis. So how do we find ix1, ix2, etc., etc.? For example, when we look at area number 1, this triangular area, what we can do is we can look up the formulas to calculate the area moment of inertia about its own centroidal axis, which is here. So this right here is at a distance, a certain distance, let's call it a d1 here. Therefore, if we can find ix1 prime bar, which is the area moment of inertia of our first component triangular shape with respect to its own centroidal axis, and then we can use parallel axis theorem. So add a1, that will be the total area of this triangular shape, and then multiply by d1 squared, which is the perpendicular distance between this centroidal axis to the target x-axis. And then we can do the same thing and then eventually add everything together. So our ix equals to, for the first one, we do the triangular shape. We need the moment of inertia about its own centroidal x1 prime axis. For that, we can go ahead and use the standard formula, like this one right here. So ix equals to 136 bh to the third power. B is the base, h is the height of the triangle. And pay attention to where the x-axis is. It is the centroidal axis. It is at a 1/3 h height from the base. So with that, we come back. We have 1 over 36 multiplied by b, the base is 4 feet, multiplied by the height of the triangle, which is 3 feet raised to the third power, that is this part, plus the area of the triangle, which is 1/2 times base times height, so 1/2 times 4 times 3, multiplied by d1 squared, this distance right here. Remember from the previous image, this right here is 1/3 of the height, which is 1 foot, plus another 3 feet from the x-axis. So overall, that will be 4 feet raised to the second power. So this part right here is our ix1. Moving on to our ix2. For our ix2, we can look up the moment of inertia about its own centroidal x-axis. So x2 prime axis, which equals to 112 bh to the third power. B, again, the same 4, height is the same 3 feet raised to the third power. And then using the parallel axis theorem, we start with the area of the rectangle, which is 4 times 3, multiplied by the d2 squared, which is this distance right here. So that is half of the 3 feet overall height. That will be 1.5 squared. So this is our ix2. Moving on to our next one, that will be for the quarter sphere. for that, again, we're going to look at the formula right here. However, if you pay attention to this right here, you see that the given formula are with respect to the x and y axes, which are not centroidal axes. In other words, we can directly use these two formulas because the x and y axes shown in this example match exactly of our x and y axis location. Okay, so again, these two equations are not about centroidal axes, but about these two x and y axes at the sides. Therefore, we're going to use the equation directly without using the parallel axis theorem. So we have simply 1/16 times pi times the radius of the sphere, which is 4 raised to the 4th power. So this is already ix3. The last one is a -1 because the area is negative. So in this case, we have this sphere right here. If we look at this circular area, again, the equations are given with respect to the centroidal axes. But in this case, x-axis is the centroidal axis for the negative circular area. Therefore, we can just use the equation directly again. That will be 1/4 pi r to the 4th power. So that's 1/4 times pi times the radius is 1 foot raised to the 4th power. So this is my minus ix4. So now we have everything set up. All we need to do is to evaluate. So this eventually evaluates to 185 in the unit of foot raised to the 4th power. So that's our first solution. All right, so moving on to the second one, IY, we're going to do the same thing. So IY, again, we start with IY1, which is the moment of inertia of this first triangular shape with respect to the y-axis. So according to, this is the centroidal axis that is parallel to the y-axis. Okay, so we will use the equation that's 136. Now the base is this much. So the base now is 3 feet. The perspective has changed. Now the height is the 4 feet raised to the 3rd power. Using the parallel axis theorem, 1/2 times 4 times 3, that is still the area of the triangle. That stays the same. But D1 now is this distance. D1 equals to 1/3 of the height, which is 4/3 raised to the 2nd power. So this is now my IY1. Moving on to the rectangular shape. About its own centroidal axis, we have 112. Again, the perspective has changed. The base is now 3. The height is now 4 raised to the 3rd power. Okay, plus the area is 4 times 3, still the same. Now the distance D2 is 2 raised to the 2nd power. So this is my IY2. Moving on to the quarter sphere, it's the same thing for this circular shape. It is still 1/6 pi to the times radius 4 raised to the 4th power, still the same. So this is again my IY3, and then minus for the circle. Its centroidal axis, which is parallel to the y-axis, is this one. So about its own centroidal axis, we have 1/4 times pi times 1 raised to the 4th power. But now we do have to use the parallel axis theorem. So we have to plus its area, which is pi r squared, 1 squared, times the distance. This right here, this 2 feet right here is our D4. And that is 2 raised to the 2nd power. So this is my minus IY4. So with that, now we're ready to do the evaluation, and that eventually evaluates to be 117 foot raised to the fourth power.